Hello, my name is John Rodriguez, and I'm an Android engineer at Duolingo. And today, I'm going to be talking about what's coming up in Paparazzi 2.0. Let's get right into it. So, before we dive in, let's do a very brief recap of what we talked about in the last droidcon NYC, or droidcon London. Sorry, so many droidcons, because it'll set some important context for then what I will be talking about. So, a major effort of the previous talk was about rewriting the resource loading mechanism within Paparazzi. If you saw the previous talks, you might have seen this slide. From the Hack Week version of Paparazzi up until a year ago, we were kind of cheating and looking into how the Android Gradle plugin merged your resources and it put it all in one directory. And this was our lazy way of just figuring out where all the resources live. There are a couple of reasons why we shouldn't have looked in there. I mean, first of all, the plugin is free to change its implementation, so we were constantly being broken and having to update. It also turns out that this worked well for library modules, not for application or dynamic feature modules, so for a while, Paparazzi had no support for that. But at the end of the day, what you kind of want to semantically have is know where the respective resources are coming from. If it's merging from third-party dependencies, if it's coming from your local project modules, you really should be referencing those directly, which is why the bottom state is more ideal. But the trick is how. So the Android Gradle plugin kind of does this for you as part of the merge resources task, which then passes a bunch of file paths to AAPT and does all the nice things that it needs to do to package your resources in a binary efficient way in your APK or AAR or AAB. But in the editor, it has no need for that. In fact, a lot of times, from an editor perspective, you're editing resources, say your string resources file, on the fly. And so it's constantly listening for file changes. And IntelliJ has this nice framework called the PSI framework that'll detect as you make changes to the file to add, delete, or update your resources, how to on the fly update that so that your compose preview, say, will render correctly. And so you're not building in the background every time you're doing that. How does that work? Basically, Android Studio has its implementation of doing so. And so we cribbed that from it. And there's this kind of hierarchical way of how you represent resources. This is the slide that kind of breaks it down a little more. If you're a third-party dependency, we'll look in your Gradle transforms directory where those resources will be exploded. If you're a local module, we'll go to your source main res where you expect it to. And then there's some extra things to handle, like your dynamic resources that you may have declared in your Gradle file. But at the end of the day, you form this hierarchy. By doing this, we were able to improve our heap usage and just tests were faster. We didn't have to also, another thing implied in this is that we were double loading framework resources. That was a kind of thing we caught. So this rewrite helped us in that. We now can support application and dynamic features by moving away from that old legacy approach. We were also using some test classes that were really old in AOSP that had bugs around it. Even Android Studio itself had moved to this new way. And so things around localization or string plurals had been broken until we moved to this new way. And also, because we're no longer bleeding into plugin implementation detail, it made it slightly easier to potentially move to another build system. The less you depend on AGP, the more you can conceivably write a Bazel plugin or what have you. We did later find out that we broke dynamic feature support in another way, and so I just want to call that out. We did advertise that, and we will be fixing that, but there's a kind of lot of moving parts. So if you follow Android Gradle plugin APIs as closely as I do, you may know that now they've moved to this like artifact API where you can ask for the APK or ask for the manifest. It's really nice. You don't have to figure out what tasks to hook into in Gradle because those can be broken. And it just so happens that we need something for dynamic feature artifacts for that to work, and I think Google is going to support it soon. Moving ahead, one other thing that we released support for was localization and locale support. So that's what the sample looks like today. Other things, Before, you had to have a full screen decor view for all your paparazzi tests. That's annoying. Do you really care about the system bars? Probably not. And so widget support was something we released. You might have heard of this thing called accessibility tests. It's really handy. Following the talkback paradigm, you're able to see what accessibility elements are assigned to your view hierarchy components. So we've been investing in that heavily. We also have a subtle feature that we really just use Android Layout Lib for, called accessibility validation. There's support in Layout Lib to do things like showing if you have low contrast and other little things that you may not be catching as you develop your screens. We also provided limited support for Android Wear. So basically, instead of rectangles, you can draw circles. A little more than that. But, and so now let's kind of move forward into today's topic. So I mentioned the resource loading mechanism for a reason. By doing some of these things, we were able to, there's this class called environment where in order for Paparazzi to start, it has to load Layout Lib. And so if you hear me, if you've never, who's never touched or worked with Paparazzi before? Who's like relatively new? Okay, so the high level thing I'll mention is like the thing that drove Layout Inspector or Compose Preview in the IDE is this library called Layout Lib, which for a long time was not its own Maven artifact. It's a Google-owned jar, and we originally dragged the jar into our IDE and hacked on it, eventually relocated it and pushed it under the Cache App coordinates to Maven Central, filed an issue on Google's issue tracker, and now they have their own artifact for it. But in that whole evolution, we were basically informed by the Android Gradle plugin where all the bits of the Android system were. So in your Android home, SDK, platforms, whatever, we wanted to know where your resource or your assets were. And by moving away from that bespoke legacy resource loading system to this system, we get to prune more things out of environment. And the theme is, that's generally a good direction we want to go. We want to eventually wean off of as much of the Android Gradle plugin as possible for reasons that I'll mention shortly. So that was one nice change. With Compose Previews, one of the things that there's like a parity race where we try to keep up with where Compose Previews are, because one of the benefits of using Layout Lib as the backing engine of Paparazzi is that any bugs that occur in the previews are also Paparazzi bugs, but you know, we can sometimes be the vector by which bugs are discovered in Layout Lib. We file it with Google, they'll fix the bug, the whole ecosystem is better for it. But one thing that was particularly interesting was with Compose, there are Android X components, or maybe you write your own components that may take multiple layout passes to render something like on global positions, callbacks, what have you. And there's been a long ongoing discussion of should we essentially keep on recomposing until there's no more pending work? Or should we be really strict, and if you're not rendered by the first frame, too bad. Historically, we've been really kind of on the strict side, and for good reasons. Like ultimately, we think if you don't have all of your layout arrangements set up by that first frame, that's a developer bug-ish, aside from animations, of course, but like things like text layout and stuff probably should render within that first frame. But what we've noticed is that even the Compose Previews in Android Studio support these kind of gotchas, and so we wanted to keep parity with Android Studio and not really be so strict. But you can see where the other extreme would be bad if we kind of supported something analogous to Espresso idling resources, where yeah, it doesn't matter how long it takes, how many layout passes it needs, we'll eventually capture it. That might also be deceiving, because you might think that your custom component is like designed correctly. And actually would be a poor experience eventually in your app. And the purpose of a UI testing library is to kind of surface that developer error sooner. So Hopefully that makes sense, but we did make an exception for this case because of callbacks in the text composable for on global position and stuff. We were getting a bunch of issues, and we thought we should fix that. And so that was how that looks in, yeah. And there you go. On text layout and on global position were two examples of that. Doubling down on support for accessibility is really important to us. We feel like we get a lot of value out of it. Accessibility, I think, should be an important focus of any app development cycle, regardless of size, and hopefully a framework like this can help help small teams that don't necessarily have a large QA staff to otherwise catch this through manual testing. And so one of the things that we supported for recently was accessibility in dialogues and sheets. And so if you use the Material 3 components for dialogues and sheets, you may know that they draw outside of the main decor view of Window Manager, they draw in another window. And so we had to update Layout Lib to do something like that. And so if you notice the right pane, it didn't catch the text in the bottom sheet until we made that fix, and now we're better for it. One subtle fix that we added as well. So when you verify your paparazzi images, if you essentially get a failure, there was a delta diff written to the file system somewhere. Now we expose it in the test report. Pretty much following what the Android screenshot plugin was doing. We're like, oh, that's kind of cool. We should do that too. It's slightly broken at the moment, but we're going to fix that very, very, very soon. Like this week, if not today. So let's talk more about Gradle stuff. So because we provide a Gradle plugin, because most Android developers are using Gradle as their build tool, it's very important for us to allow for things like cacheability, remote caching if you're using Gradle Enterprise. And so it's very easy to mess this up. For example, task inputs, a very common thing. So when we were using the old way of managing assets and resources, we were having file paths to those resources. And so one obvious thing to do is not to have absolute paths, because the location of a resource when you clone the project will not be the same as your colleagues. And so you might think that just changing this path sensitivity to relative solves the problem, except that with the Android variant system, like debug, release, build flavors, et cetera, it introduces another wrinkle, because the relative path sensitivity in Gradle does not take into account the file path itself, but rather the contents at that location. And so it was a really interesting Kaizen bug, because oftentimes your debug resource set and your release resource set will be identical, but in the few cases where they may not be is when this bug would come up. And so, and if you ran the global variant version of Paparazzi, so instead of record Paparazzi debug, if you just ran record Paparazzi, which then would iterate over all the variants, you may see a case where the debug task would succeed, but then the release task would fail because the fact that release ran second and the caching wasn't working properly, it was looking for the release resource at the debug path. And so there was these really weird Gradle bugs that were coming up. And so what we realized is that when you're dealing with variants, Android variants, avoid configurable file collection altogether and just deal with straight up paths, taking into account the relative path part yourself. You can relativize that using just Java path APIs. And then, yeah, just yet another Gradle caching issue. It's basically a corollary of the previous one, but this was with third-party dependencies where Snapshot release versions were not getting caught properly, and so we had a equivalent fix for that. And then lastly, configuration cache. How many people here actually use the configuration cache feature of Gradle? Okay, not as many as I thought. You should all try to, because it's really great, especially as your app really grows in size. Being able to not run through configuration phases in your Gradle builds can save you minutes, if not more, or seconds, if not minutes, I should say. And so it's a really hard thing to do, but once you get it working, it's really nice. And so we try to be mindful of those type of bugs as well. This was more of a byproduct of we were using older AGP APIs. We've since fixed that, but we had to do some really ugly hacks around that in the meantime. And then finally, we got a contribution from Gradle about caching of test tasks. We had a thing where when you're recording a paparazzi golden image, the snapshot output directory is where it writes that golden image as an output. And then when you verify, that same file was being used as an input, and we weren't doing it in a Gradle cohesive way. And so there's this, in Gradle Enterprise, the velocity, as they call it these days, it'll say something like overlapping outputs, and you don't really know what that is until you look at the documentation. And even after reading the documentation, you may still not be clear. So Gradle basically informed us how we could do it better, and we fixed that. So now we're pretty proud of this upcoming 1.3.5 release because we think we've finally squashed all the Gradle bugs in that one. Fingers crossed. And that's how that looks. Okay, so one other improvement. So in order to provide Jetpack Compose support, we had to do some gnarly things where we are able to depend on AARs from JVM modules, which is kind of the reverse of how it typically works. And so at first we were dragging in jars. We were basically unzipping the AARs, taking the classes.jars and dumping them into the project. It's very hacky. It's like using Gradle files instead of Maven Central. But we did this because it was just quick to iterate and we didn't have the Gradle magic script to get it working. Now we do. To kind of highlight what I'm talking about is typically if you have an Android module and you want to depend on a AAR, that's fine. That's built into the system. But the moment that you say have a JVM module and you now want to still depend on that AAR, that's not allowed by Gradle. And I gave a talk at NYC that really goes into how the variant matching system of Gradle works. I will spare you that here. But needless to say is a jar has bytecode and manifests and few things, whereas an AAR has a lot of things. ProGuard files, lint, the bytecode itself, the resources, of course, et cetera. And so there's no way for a JVM module to even know about what Android is and what artifacts it can provide. And so you have to kind of inform Gradle how to match that relationship. And so what we do here is we create some artifact identity transform here that basically says, hey, when you get a jar, just use that jar. That's what we want. We're just going to call it a different type. We're going to call this jar instead an AAR as jar. But when we get an input as AAR, we're going to actually extract the classes from that via a transform. And so Gradle transforms allow you to take a resolved dependency and transform it in some way. So if you remember Jetifier, when you were migrating from support library to Android X, it was a transform that would rewrite all the either resources or bytecode to update the package references. And so this is another transform that says, hey, when I get an AAR, ignore everything except that classes.jar, which we were doing manually before. This is just a smarter way of doing it so that now instead of every time a new release of all the Compose dependencies come out, you have to download them from Maven Central, unzip them, and do that manual work, which why would you do it that way? We do it the more intelligent way. You bump your versions toml, and it does all the extraction for you. And so that's just a diagram of explaining how that looks like. So then once you have those transforms set up, you set up something called an artifact view that says, hey, I'm going to depend on this new type, but I'm going to instead filter it on this new artifact type that I declared. Wire it as such, and really this is the end goal. It's now, as a JVM module, I have a different configuration type in Gradle that can depend on that AAR, and it knows how to get that to work. And you're wondering, why the heck do we even do this? It's because we need those types to work in your paparazzi test. The composable annotation, until you maybe now with a multi-platform world, that's probably a lot easier now, but at the time when it was only an Android artifact, this was the way you would be able to reference those types in a JVM module. So pretty important to get composable snapshots. A shining moment for me, having worked on Paparazzi for a while, was when the Jetpack Compose 1.6 release came out. Renovate bumped the dependencies for us. We didn't really think much about it, and so why would I be proud is, after the fact, we thought we had a bug in our setup, But it turns out that in the 1.6 release, the Android X team changed the default value of font padding. I forget which direction, if it went from true to false, false to true, but there was a change, and our tests caught that. And so it's very, let's see if this works. Yep, onion swipe. And so we were seeing kind of failures like this when actually they weren't failures. It was a validation that, hey, you bumped a third-party dependency, it changed something that should affect your UI, and your UI test caught it. And so that's great. And we were able to take a sigh of relief and instilled more confidence in what we've been working on for the past few years. I mentioned LayoutLib and how we used to kind of repackage it ourselves. And so although we're not as good as we like about keeping up, we try to keep parity with the IDE releases. And so if Koala or Ladybug comes out, we try to bump LayoutLib in Paparazzi in parity so that you can develop and have your tests run in a roughly similar versions. And so we've bumped from Hedgehog, we bumped to Iguana. Iguana broke a lot of things. Iguana had a lot of compose support, which was great. Prior to Iguana, the way that LayoutLib was interacting with Choreographer was doing something like analogous to Roboelectric Shadows. It wasn't actually executing the true path. As of Iguana, it did. So that's overall better, right? You're actually running more Android platform code in your tests. That's a win. But the pain was just basically now fixing the equivalent things in Paparazzi that we had been doing to support that. So that's done. It's landed. We're in a better place for it. It just was a bit of a couple of weeks of pain. And as of Jellyfish, now we've moved away from our own release of LayoutLib to the Google published version, which has huge amounts of benefits. Besides the fact that we don't have to publish that as a primary step anymore, we are also able to, one of the things that they did was they also packaged the framework resources as part of the artifact. So I guess I should just jump ahead here. We deleted a lot of code. And part of that is because one of the things, remember environment, we want to kill things from environment. And so platform dir was the thing that looked in that Android Home SDK platform yada yada file path and would look for your framework resources there. Now it's actually in your Gradle transform directory. And so why does that matter is that now the release cycle of LayoutLib, if they want to move forward to later versions of Android, can do so independently of the IDE release cycle. This is important not only for engineers who might want to have bleeding edge preview versions of Android SDKs, but even potentially Google engineers themselves who might be working on versions of Android that we haven't seen in the public releases yet can iterate on. So overall, that's great. It was also really annoying for us because we would have hard-coded regexes in Paparazzi for that SDK version, but I remember there was a sandbox privacy version that would break us, and we had to come up with these interesting hacks. Those hacks go away now. It's LayoutLib's, LayoutLib is the owner of that issue now, so it's great. Getting there wasn't easy, though. One interesting thing that we'll talk about a bit more is about anti-aliasing. By the way, how long is this for? Till when? 35, okay. So I should speed up. So anti-aliasing is a problem that came up more. The strive for pixel perfection is tough because we, historically LayoutLib was only JVM based, but then it moved to a JNI native platform, and then we were like, we should be able to support all operating systems. And for a while, that worked really well. But then you realize, or at least I realized recently, that you can't get pixel perfection for things like anti-aliasing or certain gradients. But I tried, and I really tried. And so what I realized is I started looking at how fonts are rendered on the JDK. And once you start seeing sun in your package namespace, you know you've reached a really, really dark place because you should never really look in there. But one thing I did find out is when I was trying to figure out why Mac OS was not rendering to my liking, we picked a really boring font with no anti-aliasing. but it turns out as of Mac OS 14 and above, you cannot turn off anti-aliasing. And maybe some of this is obvious to some of you, it wasn't to me. I spent hours trying to get this working. And so I had to take a different approach. And things like this were common, and what you might have noticed in Paparazzi is there's a max % difference. That was kind of our workaround to kick the can down the road. It's not great, but it's worked really well up until now. 0.01 max % difference. Even the screenshot plugin I started today started using that. But admittedly, we do not want to depend on that for much longer. Here's another example with the differ. I asked a few people, and Romain Guy, who's a specialist on the graphics side of things, suggested that there are like smart diffing algorithms that we could use, and so it's a TBD to do that. For now, I hackily realized that the RGB components of those pixels are like off by 1 or 2, so you might have seen that Paparazzi went from pixel perfect diffing to off by 2 diffing, and that's what we're shipping on 1.3.5, but it's not the end all. Like, that's a short-term workaround. Do not be scared. Please upgrade. It's still good, but we're going to try to do something better for the following release to make those comparisons a little better. All right, let me try to speed through this. So a while back, we introduced an APing reader-writer, and now we provide video support in as of 1.3.4, but I think it was broken because of other reasons, so 1.3.5 will have support for it if you haven't upgraded already. One thing to call out is if your frame rate changed in between snapshots, it will catch that as well, so you're able to really see differences. So that's a nice win. A question I get asked sometimes is why APing and not GIF? It's just a better format. APing they're both lossless, but APing supports compression, so chunking tends to be a bit smaller. It also has a better support for transparency and color palettes, so you tend to have better quality images. But yeah, that's the decision on that. And if you're really interested in reading like RFCs and stuff like that, that's a link. With that, we're able to support things like Lottie test support finally with animations, and so yeah, we can do things like this. At Duolingo, we use Rive as the animation framework, so I'm very interested in trying to see how that works there. Moving forward, we're started the work, but we have a lot more to go in splitting. Paparazzi has been historically a JUnit rule, but we think that it's capable of so much more, and so we want to start extracting that shell. I know one thing that has been asked for a while is JUnit 5 support. By extracting that out of the JUnit 4 rule, we then could conceivably have a JUnit 5 support. So I have a long-lived draft PR that I'll be getting to next week. So look out for that. One blocker in the way, though, is going back to this resource writing. I mentioned how that was a significant effort to get done. That's really half of it. So the end goal of that hierarchy is that you have a 3-dimensional map by which you can look up all your resources. And that 3-dimensional key is the namespace, which would be your Android namespace, your app namespace, whatever, res auto, your resource type, string, layout, drawable, et cetera, and then the name of the string itself. So you want to reference a resource by this resource ID. This is how it kind of gets translated into the map and ultimately points to someplace in the file system, because remember, we're not looking to build intermediates anymore. That was bad. We now look at the respective place in the file system, and so this is what that mechanism allows us to do. But the question is how do we get that key? AAPT was the thing that created r.jar. And remember, we want to move away from Android Gradle plugins, and so we have to come up a way to replace this. That's the kicker. Turns out Android Studio does that already too. Remember, as you're updating resources on the fly, it's actually using ASM bytecode to on the fly create r.jars. Poof, mind blown. So we're basically going to crib that. I kind of already did. You might you'll see a branch up there where I just copy the bytecode stuff, but now it's like draw the rest of the owl. It's like, how do you get it into Paparazzi's mechanisms? That's the work that's going to be there. But this is kind of the end goal. This is a CLI app, right? And yes, I hard code some paths because I have to figure out where it's going. But ideally, you should just be able to use Paparazzi as a snapshotter in a CLI app for whatever reasons. Maybe you want to transpose things from Figma to how it would look in Android Studio. An internal project that I was working on Cash App with some other teammates was a composed multi-platform app that would allow you to render an Android view from like a server-driven UI. And so rather than having your server engineers or your designers install Android Studio ADB emulators just to get the rendering that they want, they could just do something like this. And so There's a lot more to go. We're hopefully like a year from today at London, we could say we have this. That's the goal. We'll see. One thing we will be releasing next week or two is finally preview snapshot support for Paparazzi. This has been at work since the screenshot plugin was released by Google, so now we're releasing it, but we've had the benefit of time to kind of make improvements. And so that's going to be nice. If you have a composed preview right now, all you have to do is do that, and you'll have your Paparazzi snapshots automatically generated. We are not providing our own API for all the device configurations and parameters. We'll just look at the Google preview and preview parameters. And what it's doing in the backend is we really love test parameter injector for testing. We're basically introspecting now with the KSP plugin and generating a test source class that uses test parameter injector. When we move to this SDK down the road, we will probably eliminate that test source set because it's kind of a middle step that may be unnecessary. But for now, that is how we're going to release it, just to kind of kick the tires and get feedback and see how it goes. If you've been doing Android programming for a while, you may remember this project that Square had called Spoon. It was before the days of like Paparazzi, where espresso and UI testing on the device and emulator was really the way to do things. The reason I mention it now is they had this really nice, well, not UI nice, it's a bit antiquated at this point, but a snapshot browser. That's what I'm trying to get at. Ways to, once you have all your snapshots, go at a dimension and look at light mode or landscape or what have you, or any custom tags that you apply. Like I think Airbnb uses something called Hapo. There are plenty of players on the market that has some way of like looking through your screenshots. We'd like to provide something first party in Paparazzi, and this is kind of a light inspiration for that. So that's another thing that you should be on the lookout for. 35, right? So 3 minutes. I want to take some time now to just talk about some design opinions. These are not hills that we're dying on, but it's a question that comes up. I find myself answering a subset of questions a lot. And so what I'm hoping to do in this part is kind of explain those design opinions and hopefully either add some clarity or get feedback from you all. And if we should change our minds on some things, let's do that. But I think right now there's been just some mystery about why do we do it this way. And so one question we get a lot is, why do we use layout lib and not roboelectric native graphics, which is only recently come out? Part of the reason is it didn't exist at the time, right? I kind of just mentioned that. But another reason is that you're probably working in the IDE for Layout Inspector and Compose previews. And so for better or for worse, like having parity with that in our tests is a boon. Roboelectric has historically, with its shadow system and trying to keep up with Android platforms and developer cycles, we get it. It's a library and it's hard to keep up with things, but it had been fallen behind in the past. And so moving away from layout lib to native graphics may be great in the short term, but we don't know where that parity will lie. And then also it'll be harder on the maintainers to kind of troubleshoot bugs. It's really easy when you say there's a bug in this version of layout lib, we can open up Android Studio Ladybug and go, oh, it's there too. It's not our fault. It's layout lib's fault. So it's a kind of strategic decision at the moment. I know some companies like Uber have preferred using roboelectric native graphics. An alternative to Paparazzi, Roborazzi, I think, is a choice if you're so inclined. I don't know much about the library, but I know that they support that. But this is where we are for now, and talking to Google, layout lib is not going away. It's the investment for Compose previews, so we feel fairly confident in maintaining that stance at the moment. Okay, so another thing is about workflow. So people say, right now to run Paparazzi, you record new view, you record this, you run this command, you record, you get a golden file. Then later, either locally or on CI, you run verify, and either you did what you wanted or you got this. And this diff isn't necessarily a bad thing. It could be you changed your UI and it's now showing you the new golden value, or you have a bug, and this is what the point of the framework is. And so what you then do is decide which one it is, and then run record again, and then commit that result. And then on the Git repo, if you use the swipe feature, you'll see that there was a change. But I've also received feedback, hey, why don't, in fact, if you saw the earlier talk on screenshot plugins, they propose an alternative workflow where you upload your tests, your source and your tests, and CI generates the plugin, the golden files, you review it via a workflow, and then commit it to your repo. At the moment, we're not really supportive of that workflow. We think that's great for large organizations like Google, Uber, Meta, if you have the team to staff that. But if you're either a small org or an indie developer, an open source developer, now you had to add this extra step to your workflow, run a service, maintain that service. We recently, it's also a CI migration checklist. If you're using Travis CI today, you want to move to Circle CI tomorrow. Now that's another thing that you have to remember to migrate. Do you have the staffing? Is it a one person? Is it an outsourced effort? And so we're really trying to make it so that we can do work for the indie developer and the large organization. And we really have to try to figure out a good balance. I recently spoke on Coding with the Italians, and Yvonne mentioned about introducing a Docker image. And I do worry about total cost of ownership, but I do think that that might be a thread worth pulling on. Is, for example, if you are having artifacts, by the way, here's a link to the talk. One benefit of doing it that way is that these artifacts where we're doing the diffing, the smart diffing, they might go away. Say you're running on a Mac OS ARM laptop, but you're building on Ubuntu Linux and your artifact differences occur that way. Well, if you ran your paparazzi tests on your Docker container that runs Ubuntu, that might solve that problem, and you can go back to pixel perfection. But it's also a balance of now, do you want to run a Docker image along with giving Android Studio 64 gigs of RAM and all that? Like, it's a trade-off for sure, and we're mindful of it. But I think we want to start with a smart diffing approach first to see if we can just get that to a safe point, but we are mindful of it. So I just wanted to kind of call that out. Another thing that's a byproduct of this is I know like drop shots and other libraries really prefer to do tests on devices or emulators. I will say this is the stronger hill we're on. We really like JVM tests because they're faster. If you've ever worked in device farms or Firebase, the flakiness of emulators, the flakiness of everything around it from network to timeouts to scaling, I get it, Firebase Test Lab might be costly. I see that as a forcing function to get stuff off of a device farm and move to the JVM and figure out a mechanism to make that scale. That's the opinion we have at the moment. I understand that may not work for everyone. Some of these decisions might have been already made. But running on the JVM is really fast and scales better. We want you to run millions of tests and have millions of snapshots. Emulators tend to not perform as well as JVM tests. So that's the reason why we've made that decision. Also, this is just today's like issue tracker for emulators. There are a lot of bugs, and this is not to pick on the emulator team. Like, there's a lot of great work doing there, but it's a moving part. And so, like, that's a thing you update your JDK less often than you probably update your emulator. And so, if you're gonna run millions of tests on CI and emulators, that's a thing you'll have to factor into that maintenance. So, again, very JVM focused at the moment. It's okay if you disagree. I'm happy to talk about it more, but that's why we're kind of on that at the moment. And then the last thing, sorry I'm over time a bit, but our golden image is valuable. That came up. Why run record and check that into CI at all? I think there is benefit to having sources of truth, whether it's your data set or your source code itself. I think one thing that may make that a little stronger of a sell is when we do this snapshot browser thing, because right now you don't really, we have mechanisms to say write your own snapshot browser, but you probably aren't really looking at them except for your pull requests. It'd be nice to now make this an authoritative source of truth where your designer can look at the catalog of all your screens in the app. I mean, basically like what Hapo does and other alternatives, but like surfacing that. And so if that's the case, yeah, golden images now are more important than they are today, and we want to invest in that. Anyway, thank you for sticking with me with the both delay and going over time a bit. That's all I have. This is the project repo. Again, if you have any thoughts, discussions on what we talked about or feature requests or bug requests, please file them there and continue the conversation. We love collaborating with external contributors. Thank you.